Good morning, students. We are discussing on water resource engineering and hydrology. While in this lecture, we will discuss about some hydrological analysis. Well, to understand the analysis of the hydrologies, okay. So for that, first of all, we need to understand some terminology that is related to the flood. Okay. So for that, first of all, whenever we are analyzing the hydrological parameter, okay. So for that, first of all, we should understand that what is design flood, okay, for that particular structure or for the particular reservoir or stream or area, or else maximum probable flood that can be occur, and the standard flood and the standard project flood. Okay, so these are some terminology. We are starting with the flood. Well, what is design flood? Well, the maximum flood that any structure can safely pass, that is called as the design flood. Well, a design flood is the flood discharge that adopted for the design of a structure after careful consideration of economic and hydrological parameters, or the factors we can say. Well, while designing any important hydrologic structure such as a dam or anything else, then provision must be made for the flood that is likely to occur during the life of that particular structure. So that is about the design flood. Okay, the next, that is the maximum probable flood. Well, the maximum probable flood is the flood that may be expected from the most severe combination of critical meteorologic and hydrologic conditions that are reasonably possible in the region. It is estimated that from the maximum probable storm, applying the unit hydrograph principle, the maximum probable storm is an estimate of the physical upper limit to storm rainfall over the basin. The third terminology, that is the standard project flood. Well, the standard project flood is a flood that may be expected from the most severe combination of meteorologic and hydrologic conditions that are reasonably possible in that particular region. The standard project storm rainfall may be taken as the largest storm rainfall which has occurred in that particular region of basin during the period of weather record. Now let me see the few methods of estimating the maximum probable flood. Well, for that we have some methods. The first, that is the past flood method, then the empirical methods, then envelope curves method, concentration methods, rational method, unit hydrograph method, and the flood frequency method. So these 7 are the methods for the estimation of maximum flood. So let's brief about that methods. First method, that is the past flood method. Well, the maximum flood that occurred in the past can be estimated from the flood marks that left by the flood. Well, these marks are generally in the form of floating debris sticking to the banks or to the walls of the structures at the riverbank. Well, a reliable estimate of the flood marks can also be made by making the inquiries from a number of old persons living in the village near the river. Generally, such persons have the memory of the highest flood during their lifetime or during the time of their forefathers. Well, this method is not reliable. It should be used only when when the other methods cannot be used. Well, the second method, that is the empirical methods. For in this method, we will have some different formulas to find out the discharge and other terminologies. Well, various investigations gave empirical formula for the determination of the peak discharge. However, these formula are applicable only for the type of catchment and the region for which they are developed. So for that, some formulas that we are having, and this formula are not reliable and are used only when other methods cannot be used. Okay, so the first formula, that is the Dicken's formula. Well, according to the Dicken's formula, he has given a peak discharge formula as Q is equal to C into A raised to 3 by 4. This formula was developed for the North and Central India. Well, here the Q is nothing but the maximum flood discharge, that is in Qmax, and and A is the area of the catchment, while C is the Dicken's coefficient. Well, here the maximum observed value of the coefficient C, that is around 35, and the value of C should be selected based on the local experiences. Okay, so there may be possibility that the coefficient of that the Dicken's coefficient may vary. Okay, so the formula is occasionally used for the catchments of moderate size, while the second, that is the WREH's formula. Well, this formula was developed for the Tamil Nadu region. Well, it is also used for the catchment in the South India, in Karnataka and Andhra Pradesh. Well, according to this formula, Q is equals to C into A raised to 2 by 3. Well, again, C is the WREH's coefficient, and the value of this C, that is 6.8 for the area within the 24 kilometers of the east coast. Well, it is 8.5 for the areas that is between 24 to 116 kilometers from the east coast, and also near the hills and mountains this value changes as 10. The maximum value of C, that is about 30, that has been observed, and again A is nothing but the area of catchment. And the third, that is the English formula. While English formula was developed for the catchment area that is in Maharashtra, and for that the peak discharge value, that Q is equals to 124A divided by under root A plus 10.4. Here also A is nothing but the catchment area. The fourth, that is the Ali Nawaz Jung Bahadur's formula. Well, this formula was derived for the catchment in the former Hyderabad state, that is in Andhra Pradesh. Well, for that, the value of peak discharge, that is C into 0.386 A raised to N, where this N value is denoted or is stated as 0.925 minus 1 by 40 log 0.386 A base 10. Here again, C is nothing but the coefficient, area is denoted as A, and Q is the discharge. Well, here again C is varies from 48 to 60 value, and the maximum value of C, that is observed as 85. This formula is commonly used for the catchment area in the Andhra Pradesh. Well, the fifth one, that is the Mayer's formula, and for that the value of Q, that is 176 P into A raised to 1 by 2. Here P is the coefficient which depends on the frequency of the flood with a maximum value of unity, and A is nothing but the area of catchment. And the last, that is the Fuller's formula. Well, that is also developed in USA, and here the value of peak discharge is Q bar into 1 plus 0.8 log TR base 10. Well, here the Q bar is maximum 24-hour flood with a return period of TR years. Area, A is the area and C is the coefficient whose value, that is, varies between 0.18 to 1.88. Well, here TR is nothing but the return period. Now the third method, that is the envelope curves method. Well, for plotting the envelope curves, the maximum flow discharge for the catchment having the similar topographical features and the climatic conditions that are determined. The maximum flow discharge is plotted against the area of the catchment, and a curve is then drawn to envelop the highest plotted scattered points. If a log paper is used, the envelope curve is usually a straight line, and the envelope curve can be used to determine the maximum flow discharge in the future for the different catchment areas. Well, with that, Bad and Milrate studied the maximum recorded flood throughout the world and gave a formula for the envelope curves method. And that formula for peak discharge, that is Q is equals to 3.025 A upon 278 plus A raised to 0.78, where again A is the area of the catchment. So this was about the envelope curves method. The fourth one, that is the concentration time method. While the concentration time is the time taken by the water to flow from the farthest point of the catchment to reach the outlet, while the discharge at the outlet is a maximum when the duration of the storm is equal to or the greater than the concentration time. The concentration time depends upon the length of the basin. It depends upon the average shape. That is, with the concentration time method, the value of concentration time can be estimated by the Kirpitz formula, that is 0.0195 L raised to 0.77 upon S raised to 0.385, where this L is the length of the basin and S is the average slope. Now talking about the fifth one, that is the rational method. In this method, it is assumed that the maximum flood flow is produced by a certain rainfall intensity which lasts for a time equal to or the greater than the period of concentration time. When a storm continues beyond the concentration time, every part of the catchment would be contributing to the runoff at the outlet, and therefore it represents the condition of the peak runoff. The the runoff rate corresponding to this condition is given by Q, and the value is 2.78 C into IC into A, where this IC is the critical intensity of rainfall corresponding to the time of concentration of the catchment for a given recurrence interval obtained from the intensity duration frequency curve, while C is the coefficient which depends upon the characteristics of the catchment, A is the area of catchment, and Q is the discharge. While the sixth one, that is the unit hydrograph method. Well, the flood hydrograph and unit hydrograph that we are already studied in the previous lectures. Okay, now when a unit hydrograph is available for the catchment under the some consideration, it can be applied to the design storm to yield the design flood hydrograph, from which the peak flood value can be obtained. Whenever it is possible, it is advisable to use the unit hydrograph method to obtain the peak flood. It gives not only the peak flood value but also the complete flood hydrograph, which is essentially required in fixing the spillway capacity after the incorporating the effect of storage of the reservoir. When the area of the basin is very large, it is better to use the frequency analysis method. So let's discuss about the last one, that is the frequency analysis method. This is the best out of all the earlier methods that we have discussed. In this method, on the basis of the past record of the maximum flood discharge, the predictors for the maximum flood discharge which may occur in future are made by determining the flood frequency and using the probability concept. While the floods are extremely complex natural events, it is very difficult to model the flood analytically, as it is the outcome of many components or many parameters. Therefore, the estimation of the peak flood is a complex problem leading to many approaches. While frequency analysis makes use of the observed data in the past to predict the future, while it is based on some assumptions that the combination of the numerous factors which produce floods are a matter of pure chance and therefore are subjected to analysis according to the mathematical theory of probability. Well, for this probability theory, we need to understand some terminology again. As we have discussed that in this method, the predictions for the future flood are made on the basis of the available data. So for that, we have to understand the probability of flood, or we can say the frequency of the flood. While the flood frequency means the number of times the flood of given magnitude will be equaled or exceeded in any of the year or any of the previous year. It is usually expressed in percentage. Well, thus a 20% frequency of a flood means that there are 20 out of 100 chances of the flood being equaled or exceeded in any of the year. Okay, so flood frequency may also be expressed in the terms of recurrence interval or return period. The next terminology, that is the return period or the recurrence interval. It is defined as the number of years in which a flood can be expected once, or a flood of given magnitude will be equaled or exceeded only once. Okay, so it is usually denoted as a T, while this probability is T is equals to 1 upon P, where the P is the probability of the flood. Okay, the third, that is the probability of occurrence. Well, the probability of an event that being equaled or exceeded in any one year is the probability of its occurrence. This probability of occurrence are accidents generally represented by P, and the value of this P is 1 upon T, where T is the recurrence, or we can say the return period. The last, that is the probability of non-occurrence, that is the Q, that is denoted as a Q. Well, if the probability of occurrence of an event is P, and then the probability of its non-occurrence in any one year is given by Q, which will be equals to 1 minus P. Okay, so these sevens are the methods of estimating the maximum flood. Thank you so much, students. I hope you understand all these methods properly. Thank you so much for your kind attention. I will see you in the next lecture. Thank you.